In this video, I'm going to walk through some of the troubleshooting that you can do when you're doing a biomart search using phenotypes. One of the things that I think will help is explaining a little bit about the structure of the function getBM. So when we run the biomart tool, the only way we're able to run this function right here, getBM, get biomart data, is if we have successfully installed the biomart package from Bioconductor. It takes a really long time to install this package. So one thing I've done for myself to make sure that I only install the package once is I've set up a separate R script for the little code snippet from Bioconductor. I've copied this directly from the Bioconductor website. All right, so right here, if require BioC manager, and I have set it as its own script, I made sure that I only ran that once, and then once I knew that the package had been installed in this workspace, I close that script and I make sure that I don't run it again. Every time I start up R, I do not need to reinstall biomart. I only need to run the library biomart command. So that is the first line of my markdown file. And my first code chunk is just run library biomart. I run that and I see that it works, and I'm all set and ready to go. Now, the second code chunk is to define the 4 variables that are going to go into the getBiomart function. Before we look at how to define those 4 variables, let's look at what order they go into the function and what kind of data we're looking for in each of these. So we have attributes, followed by filters, followed by values, followed by the mart. In many of my previous code examples, I've done this little trick just to show you what goes at each spot, writing mart equals, values equals. You don't need to specify that, and so this might be a cleaner way for you to organize your code. Just make sure that you put the variable for attributes and that it's a value, that it's being stored in your environment as a vector. Filter, values, these should all be values and not data. We don't want to put data frames in these first 3 positions in the getBiomart function. And then the last object, ensemble, should not appear in values. It should appear up here in data because it's a special type of data. It's a formal class mart. And you can click down to see the information about it, to see which mart you've selected, or you can even double click on it to read it. And we need to make sure for this project, which is about variation and about looking at single nucleotide polymorphisms, that we've selected ensemble mart SNP and that we've selected the data set within there for Homo sapiens, so H sapiens SNP. Once you have kind of wrapped your head around 4 variables you want to create, you can go back and make a little code chunk that makes each of those variables. So the mart we want to select, ensemble use mart, ensemble mart SNP, dataset Homo sapiens SNP. For the filter, we can look at each of the filter options by having a variable that lists the filters. So if I double click on this, I'll see in a data frame all the choices that would be on the pull down menu if I was on the website. And I can see, okay, chromosome name, marker, study name, phenotype description, SNP filter. This is what we used for the first assignment this week. And then phenotype description is what we're using for the second half of the assignments. So I'm setting my filter to phenotype description. And the best practice is to copy it directly from here to make sure that you get the capitalization and the underscore in the right place. Next, I'll create a variable values to go into phenotype description. There are so many options for phenotype description. I've actually provided you that file on Dropbox. And what I've done in this example is I've just taken the first 2 from the list and put them into a single variable called my values. What you want to do for your project, because each of you are looking at a different phenotype, is you want to use string detect to find things within this list that match a key search term that you're looking for. So for example, if few people are looking at intelligence, they could look for the word intelligence or brain volume or brain structure, any of those keywords. Once you have defined your values and you need to define your attributes. Attributes are the columns of data that you're downloading. Again, it's hard to know what all your choices are, so that's why the list attributes command for the mart that you picked is really helpful. I can then look at that variable I created as a data frame and see all the choices I have for information that I can download. So for every SNP in the database, I can get the ref SNP ID. I need at least that because I'm going to use that to merge the data with the 23andMe file. And then there's all these other choices of information that we can download to get information about how this affects human health. So you can look for validated, you can look for translation start, you can look for DOI, the digital object identifier, to get the paper that goes with the evidence. You can look for phenotype description, associated variant risk allele, p-value, just lots of interesting choices. And your goal in this project is to choose the variables that have information for the SNPs related to your disease or condition. So once you've defined each of these 4 variables, the mart, ensemble, the filter, my filter, the values, the types of phenotypes that match the phenotype descriptions in the large 15,000 row file, and my attributes, you're ready to run your search. And once you run your search, you will get results with columns for all the information you specified in attributes and any SNPs in the database that match these phenotypes. Because I only picked 2 phenotypes and they were very specific, they're the first 2 in the phenotypes option file, I only end up with 2 rows, but I have done a successful biomart search. Reach out if you run into any other issues, but hopefully seeing the structure of the search will help you troubleshoot any problems that you're having with formatting as you try to get information about your specific phenotype.